pada pagi ini kita sangat bertuah kerana dapat sama-sama kita menyertai program webinar yang akan disampaikan oleh dua penceramah daripada Techsource Sedang Berhad. Tajuk webinar kita pada pagi ini adalah MATLAB Enhancing Teaching, Learning and Accelerated Research. Ya. Saya juga mengucapkan ribuan terima kasih kepada pejabat TNC Pendidikan yang menjadi sekretariat utama untuk memungkinkan program pada pagi ini. Ya. Tujuan utama webinar ini dijalankan adalah untuk memperkenalkan yang pertama, untuk memperkenalkan MATLAB ya, sebagai kaedah, bukan saja sebagai analisis saintifik, tetapi juga analisis saintifik untuk pendidikan, tetapi ia juga boleh membantu sebagai bahan pengajaran ataupun kaedah pengajaran, terutama sekali apabila kita sedang mengalami situasi yang disebabkan COVID-19 ini. Kebanyakan makmal kita tidak dapat beroperasi dengan sepenuhnya. Jadi kemungkinan besarlah kita boleh menilai ataupun mengkaji kemungkinan penggunaan MATLAB ini sebagai menggantikan physical lab yang tidak dapat dijalankan itu, ya. Itu objektif tujuan yang pertama. Tujuan yang kedua juga adalah untuk yang juga penting, mendapatkan respon staf UiTM supaya kita dapat sama-sama menyokong penggunaan MATLAB menerusi campus wide license, ya. Jadi sekejap lagi sekretariat akan memberikan borang kedatangan. Borang yang sama juga akan kita jadikan sebagai borang soal selidik yang akan bertanya berkenaan adakah tuan-tuan mahu menggunakan campus wide license ini. Ya, campus wide license ini adalah license yang diberi kepada kita untuk kita download dan kita run MATLAB pada PC kita sendiri. Ya, dengan cara itu student kita contohnya boleh run pada PC mereka dan membantu kerja-kerja pembelajaran dan juga pendidikan kita sendiri, ya. Okey, pada pagi ini kita akan ada dua penceramah iaitu Siti Safwana dan Dr. Hanim. Ya, saya akan bacakan dulu biodata sedikitlah berkenaan Cik Siti Safwana ini. Siti Safwana is an application engineer Techsource system. She specializes in the field of image processing, computer vision, machine learning, and deep learning with MATLAB. Before joining Techsource system in 2018, she worked at Techlois in Selangor as CRM and ERP consultant in the IT field. Siti Safwana holds Master in Mechanical Engineering in Electronic from University Technical Malaysia and Bachelor of Engineering in Computer Communication System daripada Universiti Putra Malaysia. Okay, she did her research in computer vision field in domain of depth disparity map and 3D reconstruction for her master's thesis at UTM under Department of Faculty of Electronic and Computer Engineering. Yeah. Okay. Without further ado, akan serahkan kepada penceramah kita Siti Safwana, tetapi minta Encik Andrew dari Technical Manager daripada Techsource System untuk memberi sedikit opening remark dan seterusnya menyerahkan sesi webinar kita kepada Siti Safwana. Ya. Okay.
Yeah, thank you, Dr. Faisal. Hi, good morning, everybody. I'm Andrew, account manager in Techsource System. So I've been working with Dr. Faisal to have this webinar, and honestly, I have to thank you guys for joining this webinar, for taking the time to join this webinar. So as as what Dr. Faisal has said, I have given, I was the one who has given UITM the free campus-wide license for the time being until the 31st of July, where you guys can access this MATLAB license, as well as being able to, because of the recent events, I've given this. This is one of the ways where you guys can access MATLAB, not just from the campus, but also from wherever you are, regardless whether you're working from home or you're working elsewhere outside of campus. One of the reasons why we are doing this webinar as well is actually to expose you guys to some of the applications that can be done using MATLAB, not just for research, but also for teaching. So that's why the title, Enhance Teaching, Learning, and Accelerate Research. So I don't want to talk so much. I'm going to pass this over to my first application engineer, Dr. Siti. So she will be talking a bit on the applications of how you can use MATLAB for certain applications, and hopefully that will be useful for all of you, and hopefully we can see you implement this in whether is it research or whatever classes that you're intending to do. So I'll pass this over to Siti now. Siti, you can take over.
Sorry once again for the technical issue just now. So again, thank you everybody for attending this webinar. Assalamualaikum and hi. So before we begin this webinar, let me shortly introduce myself. Thank you again, Dr. Faisal, for introducing myself. But my name is Siti Safwana. I am an application engineer from Techsource, who based in Penang, Malaysia, and then I cover most area of image processing, some computer vision technique, and data analytics such as machine learning, deep learning. And together with me is Dr. Hanim, who specializes in area of optimization and microgrid sectors. So let's proceed, Hanim. Okay. Before we proceed, today's agenda, I would like to share some image processing or computer vision application or features. So basically, this is the common IPCV or image processing or computer vision application. So in image processing, we got some import, display, and exploration of the image, and geometry transformation and image registration. Also, we have the main function of image processing, which is image filtering and enhancement. Also, and image segmentation and analysis. Also, in the image processing, and last but not least is 3D volumetric processing. For the computer vision application, we do have like camera calibration and 3D calibration for doing like depth estimation or stereo camera calibration, and we do have like tracking and motion estimation, feature detection and extraction in under computer vision field. LiDAR and point cloud processing and deep learning is also in the computer vision application. So next. Hanim? Okay. Image processing deal with manipulations. Before we proceed, I would like to tell you the differences between image processing and computer vision. Basically, image processing deal with the manipulation of the pixel within in an image. So it's either you want to do some mathematical operation for those matrices like sum, minus, or SSD, SAD, and etc. For example, here you can see like an image is 3 by 3.
Siti, hold on a bit.
Right.
Yeah, okay. I think there are some who are not able to see the slides. Can just a short. Can someone just type on the chat whether they can see the slides or they cannot see the slides? I think there are some who can see and some who cannot see. Yeah, so like Emilia is not able to see. And also I think even from my side there's one person who also can't see. Okay, yeah, maybe there was a mistake. Now I'm gonna see 250 people reply that they can see the slides.
I think majority can see, right?
Yeah, I think majority can see. So okay, so what's gonna happen towards at the end of it, we will do not worry about the slides. We will also send these slides over to you guys as well. So maybe we'll just go on with this. If there's any issues, any questions, you can just drop it on the chat, and I will do my best to follow up on that as well. Yeah. Okay. Sorry, Siti, you can continue. Yeah.
All right. Okay. For example, here you can see like image of 3x3. So you can filter out the pixel which you have a lower values of the pixel. So we apply some threshold to the image. So the computer read the image by counting the pixel as a file for the image processing. While for the computer vision is a extended image processing by using the image and video to understand the real world scene by detecting, classifying and identifying objects and events. So again, for this example, the computer read the image as a letter L. So the two domains go hands in hands together. Image processing is often done prior to using computer vision to learn something about the image. All right, next. So why are we using MATLAB? First, it is a high performance language for technical computing where it's really easy to use and offers easy syntax. MATLAB also comes with a great documentation, could build in example and create several of apps to accelerate the process. Other than that, MATLAB also provides technical support. Speaking of the app just now, here the example of the apps that built from the network for image processing and computer vision. There's more than 10 apps that were created. It's just not visual and interactive algorithm development, but it also comes with auto function generation where it's able to rapidly be prototyping as the result will be productivity will boost. So finally, with all the works has been done, we can be used code generation where you can generate C or C++, even HDL or GPU code from your MATLAB script. And this can save your time to redo the code from the scratch. So now we go to the example, the agenda for today's. This is basically what we are going to cover. We cover image processing workflow. We want to know what image morphology and segmentation. Also some application of computer vision, which is object detection and tracking. And we also touch on deep learning and summary for this webinar. So let's go to the image processing workflow. First, image processing workflow which covers of 3 steps, which is first you need to access the data. And data here, obviously, image because it's an image processing, and the data is from your file or local file, even from your hardware, such as even your camera. And if your image stored in the software such as a database, you can also access it within MATLAB function and apps. Then we go to the explore and discovery. For this part, we focus on today. So we'll iterate on this step to get the result we want. Then look the scale to automate our analysis. Then after we have done the previous 2 steps, when we build the application and algorithm, we can deploy it to the embedded device and scale them up to the cloud or generate document and report. So this is where you can deploy it directly to your hardware by using the coder just now I mentioned, and or you can also create the enterprise applications such as web apps or standalone application, or if you want to do reporting, you can just convert it to your PDF file, HTML file, or even document. So now we go to next slide, which is image processing workflow on access data. So for image processing, images in MATLAB, we do support like LiDAR sensor where you can stream point cloud directly into MATLAB for further analysis. We do have also hardware support package for various models of webcams such as Apple, Logitech, Microsoft, Philips, and Creative. And we also support Rosnode. Last but not least, we also support selected stereo camera like Intel Real or ZED stereo camera for you to do like the estimation process. So now we go to the IPCV apps accelerate workflow. So this is image processing computer vision where it shipped with many apps that accelerate the workflow. So they provide interactively tool to tweaking the parameter and visualizing the result. When you finish developing an algorithm, you can export the result or generate a function to scale your algorithm to a larger data set. So next we go to the morphology and the segmentation. So before we begin, so basically this is morphology. So can you please play the video, Hanim? So morphology is a broad of a set of image processing operation that process image based on shapes. In the morphology operation, each pixel in the image is adjusted based on the value of other pixel in its neighborhood. So by choosing the size of the shape of the neighborhood, you can construct morphological operation that is sensitive to the specific shape in the input image. So image segmentation is commonly used technique in digital image processing that can analyze your image into multiple part of the regions. So often based on the characteristic of the pixel in the image. Image segmentation also could involve separating foreground and background or clustering region of the pixel based on similarities of color or shape. So now we go to image morphology operation, which is dilation. So can you please play the video? All right. Dilation add a pixel to the boundaries of the object in the image. The value of the output pixel is a maximum value of the all pixels in the neighborhood. So morphological dilation make the object more visible and fill in the small hole in the objects. So we can see the video how it can fill the hole by using the neighborhoods function pixel in the neighborhood. So now we go to image morphology erosion. Next, all right. So while in erosion, it's remove the pixel on the object's boundaries. Can you play the video, Hanim? All right. The value of the output pixel is the minimum value of the all pixels in the neighborhood. So morphological or erosion remove islands and the small object so that only substantive object remains. Right. So next we go to the image morphology example. So before we want to count the spoke, the white spoke in the test pattern image. So if you can zoom in the center, you can see that the image is grayscale, even though it appears from afar to be a binary. As a first step, we need to decide where one spoke ends to another. So this is a segmentation process, by the way. One on the right, we can see the simple threshold-based binarization or segmentation. But even here, we click. Can you click one? Okay, but even here, you can see that the counting block is potentially problematic. So in a four connected analysis, every diagonally isolated cluster of a pixel is considered to be separate region. So this leads to a significant overcounting of a region of that spoke, by the way. So in other hand, click, please. All right, you can see the 8 connected analysis. So diagonally, adjacent spoke the considered to compromise the same region, so leading us to count the spoke. So we'll overcome this issue later on by using that unclear borders and other certain built-in functions at MATLAB. So in letters, I would say demo. So now we go to image segmentation. This is the unclear borders and image open, so we can overcome the limitation that I just mentioned just now. So now we go to the image segmentation. So this in the previous slide, so when we converted the grayscale image to the patterns in the binary, we segmented the image. Segmentation refers to the process of creating masks of an image, such as ROI, region of interest, having similar trait assigned to the same value. This is we make associate between the pixel in the image. The associations region of interest could be based on intensity, color, texture, shape, position, and etc. So binary segmentation separate the images into two classes, whether it's true or false. Is true belong to white and false goes to the blacks. But you can actually make any numbers of segmentation masks for single team in image processing, so we can download it in the file agents. We also have the image segmenter. This is the official one. So this build come together with the image processing toolbox. This image segmenter apps provide access to many different ways to segment an image. Using the image segmenter can be iterative process where you can try several of the segmentation options. So we do also have color thresholder segment. It will segment an image and create a binary mask also. And last but not least, we do have an image region analyzer. So this apps it can browse or measure and filter set of properties for each connected component in the image that you're working on. So now we go to the demo. All right. Previously, we look on the workflows. So before we start, okay. Previously, we look at the workflow where we did some segmentation. Now we will see how morphology is used in the combination with segmentation. So now we use the morphology and segmentation to extract the meaningful results. So the demo will also give you a chance to explore new feature within the same apps that we use that I mentioned before this. So can you please play the video, Hanim? So bear in mind, this is a pre-recorded video, and first, what I'm doing is I'm just created 2D image, which is consists of 7x5 window size. All right. This is something similar like this one. Then we want to use morphology for this image. So remember, we do have the dilation and erosion. So before I'm using the dilation, we need to do the morphological structural element. So in this trail, okay, we can open the documentation how we want to use the morphological structural element. Here, this the documentation inside the MATLAB. You can just DOC and dilate. So the trail come with several technique of the morphological technique. For example, like line, disc, diamond, and then etc. So for the example, I just use line, and the window size is 3 and the degree is 90. So when I apply and dilate with this to this particular image, and this is the result. So this is basically more or less same with the video that I just using before this. Now you can, this is the live script of the MATLAB. So you can see the output is, you can either view inside this live script, and you can view side by side or bottom. And then second, I use the erosion technique by using the same trail, but this one is instead I'm dilate, I'm erode. So the image become minimum. So I hope you can see the differences between dilation and erosion. Now, what we're going to do is we want to count the rise or grain by using the morphological operation and segmentation. So again, I'm using morphological element this in this example. So before start the analysis, I want to convert it into the binary image. So just using image binaries. So what we can do is this will convert your grayscale image or to your 2D image to binary, which is false or true, 0 or 1. So then I'm using image top hats filter to normalize the background. And then I want to remove the small blob. So what I'm using is blank and white array open. You can go to the documentation. Please read the documentation. What is the parameter state there? For example, this one, I'm using the image, and then remove the pixel. Has 10 pixels lowers. For example, this is the original image, and then once I remove, this is the output. I'm open the image region analyzer. So this is why I want to remove the larger blob that connected with each other. Remember just now is the threshold size is 244. So it's literally will show all the connected component in this image region analyzer, which you can see area is larger than 244 is mean that connected pixel is there. So I don't want that. So I want to remove this threshold size is greater than 244. What I can do is inside this image region analyzer also you get some properties of the connected image such as major access length, minor access length, and etc. So this is the properties of this image. So how we want to remove that thing is we go to the filter later on, and then we can specify the area that we want. So example, I want the area between 0 and play safe, like I just put 250, and it will automatically remove the connected component just now. And the original counting block is 96. After I apply that filter, is written, the result is 92. This is the example how you can do within the apps. And once you satisfy, you can just export function by using the export tool. It will automatically generate the function that you already done in the apps, or you can just export it to the workspace so you can do the further analysis. So for example, this is you can export it to the workspace, and it's just a binary of mask binary, and it will appear on black and white one. So basically, this is for the further analysis. Then next, we finish on this demo. So next, Hanim, next. All right. So the key takeaways is dilation and erosion are building blocks of common morphological operation. So morphology and segmentation we can use together to extract meaningful information from the images. Then next we go to the object detection and tracking. This is one of the example of computer vision techniques. So computer vision is all about analyzing and understanding image at a higher level. For example, the images you see here are the same object, a cameraman and his camera. The only differences is the one is rotated and scaled with respect to another's, but they contain the same significance structures in an image, which allow us as a human to recognize how they contain the same object. As a computer, it recognizes object as well by computing mathematical description of important structures. So next, the structures are called features. For example, here is a queen of diamonds. We identify the number of the important features here. The idea is we can see the same configuration of features in another's image. We could reasonably assume there's exists of a queen of diamonds in the image. So now if you can find important features, you can also sort of a cool thing like tracking this face person over here when they remove to frame from frame. And you can so what you can see in this image, this is a car, landmarking, tree, and etc. We can easily perceive this as human, but how can you could describe this object to a machine? So that's where you can come with the image features to the machine. So next, there's a mathematical operation that can describe image at a higher level than a pixel, or 1 and 0. For example, here you can just do edge detection algorithm or corner detection, whereas there are 2 edge meets or even sophisticated that complex algorithms such as surf or mesh and many more. So once the features can be abstract, so the mathematical derivation for the image. As quick example here, pictorial represent of the surf feature, which is kind of sort of a wavelet of frequency domain representation of this image region. So now we're going to see the object detection workflow. In order to do that, we have the 3 steps. First, you need to detect the features. For example, this one, we want to detect this box into the second image. So what the features is, this box is something like the green area just now inside this image. So detecting features mean to select region of the image with the unique content. This gives us a location where it's important content may exist. After we detect, we do the features extraction. So it's meant to compute the descriptor, which is representation of the feature. This is usually some additional information derived from the local region around that features was detected in the step 1. Lastly, we match the features. For matching features mean to find the corresponding feature point between the two images, which is enough feature point that you can possibly detect for the whole object. So the purpose of this detect, extract, and match workflow is to arrive a geometric transformation between the original image and the target image. So this is required you to find many match points as possible. This will become more clear as we all go through the next slide. Right. So what is the geometric transformation? As I mentioned before this, the purpose of the detect, extract, match is to ultimately find a geometric transformation. A geometric transformation is generally a metric that describes a coordinate transformation. So you may recall the linear algebra that the operation is changing from 2D xy point from one coordinate system to another is encapsulated it's in a 3x3 metric. This is sufficient to fully describe any rotation, translate, or skewing that happen to all points in the vector space. This transformation metric is so versatile, it allows us to detect objects, correct the orientation, and track them to frame, and so on. So let's go to the demo, how you can do tracking. For example, here you want to track our target image. Can you play the video, Hanim? Okay, thank you. For example, we want to detect the block just now. So for the block image and then the target image or the scene image. So how we want to do is, all right, this is the block image that we want to detect the second image or target image. What we can do is use the same technique, detect, extract, and mesh. There's several options for detect features. We can have like corner point, breeze point, surf point, and etc. You can just pick any point that you desire. For example, this is a brick point. Okay, and I can also change to another such as surf features. So once I already have the detect point, I use the extract function, extract features, and again there's several technique, but I just use auto to make the best decision for me. Once I already have the extract features, I mesh them by using mesh features function. Once I already have the mesh feature function, it will show me the right features for the both image. As you can see, there's a number of the point that not mesh. We call it as a outlier. So what we can do is we can use estimate geometry transformation function to remove the outlier. For example, here, once you apply this function, the outlier is no longer exist in that particular image. So that's outlier. Basically, that function will return transformation metric, the T form. So what we want here is the geometric transform or T form to detect the new coordinate to the next frame. So we just use that T form. Other than that, we also have the image registration apps where we can perform the same step that I done just now. For example, we just use the both image as the input, and it will automatically find the right feature for me and the measure point. So this is a several feature technique offered inside these apps, and it will automatically select. You can even select the features parameter, and once you already have the point, you can export it to workspace or even the generate function. This is the function that generated that from the apps. You can just use this to automate your process to others images. Here, this is the fourth step that I mentioned. So next, Hanim. So key takeaway is you can perform the computer vision technique by using this tracking and object detection. So feature is very meaningful structure within an image. Computer is feature to understand the image. For the object detection, we get three main step, which is detect, extract, and mesh. While for the tracking, we add additional step, which is track. So next, Next slide, please. So far, in all our example of object detection and tracking, we had referring image of the object that we would compare to a new image, which allow us to detect object. So what if but in many cases, object detection is done without a reference image, such as license plate recognition of a vehicle or toolbox, or AI assistant that can automatically recognize object. In this case, the reference image is replaced by a model. So a model is representation of a certain object that has been learned by a computer, such as the model typically arise from the machine learning or deep learning or even the AI algorithm. So the basic is that instead of using a single image as the reference, an entire set of image can be used as a reference by learning the essential characteristic of the reference object. So this is machine learning being used to perform object detection, and it is a topic that we cover and elsewhere. So I will pass this presentation to Hanim, to talk about deep learning step. So.
All right. Thanks, Siti. Assalamualaikum and good morning. This is Hanim. So for the next topic, we will be looking at deep learning as the continuation of what Siti has presented. Now, you may have heard of artificial intelligence, or AI for short. Like Deep Blue was the chess game that beat the world champion back in the 90s, and then fuzzy logic inside your washing machines to save energy, and many more examples. So among the famous techniques, there is machine learning, which mimics humans and animals' way of thinking, so which is to learn through experience. Now, the subset of machine learning is deep learning, where it detects features in a data set. So for example, the computer is given 3 image folders. One folder is of car images, one folder is of truck images, and another one for bicycle images. So what the computer would do is to learn the features that can help it label the object. Now, let's say car is medium-sized, and it has 4 tires. Then a truck is large and has 8 tires maybe, and then bicycle, small, has 2 tires. So all these features, we don't tell the computer about it. It tries to figure everything out by itself through the features pattern that it sees inside those images. Now you can think of then we have a series of hidden layers with each performing different tasks for determining the characteristics of those car images or truck images and bicycle. Then finally, we have an output layer which can perform classification. Our data that we use to train the network gets propagated through these layers to create a model for our data. So you can think of this as the human brain. This is a typical neural network architecture. So imagine the input layer are your eyes for perception. Then hidden layers are within your brain. Infos are being passed here and there through your synapses and neuron of the brain. And then until it comes to the output layer, which signifies the brain's response to the image that the eye or the input layer has seen. Now, in real world, the deep learning application is being implemented in large companies such as Shell for oil exploration through seismic data analysis. Then we have Veoneer in the automotive field for LiDAR sensor that detects obstacles. Then we have Genentech. This is in the medical line for detecting tumor. Then Caterpillar, it uses object detection to classify its equipment. Now, in MATLAB, there are many apps to assist in the deep learning tasks, depending on the domain, such as what Siti has shown for computer vision and image processing. There are also in like model-based design or signal processing, which covers on control systems, audio processing, and sensor data analytics, so on and so forth. Now, of course, MATLAB is well known for its simplicity in performing complicated tasks. So to build a deep learning network, there's an app for that. which is called Deep Network Designer, where you can just drag and drop the neural network layers. Let's take a look at a demo for it. This is how to detect the digits between 0 to 9 based on handwriting. Sometimes people's handwriting is neat, sometimes it's not, and unreadable. So we'll use deep learning to read it digitally for us. So first thing first is to load up the number of images from a dataset called MNIST. It is used to train the deep learning. There are subfolders labeled for it from 0, 1, 2, 3 up until 9. So this serves as the label for the training data. Then the term train here is where the computer learns observation by observation, because it wants to know which number belongs to which class. So we'll go to the next step later where the computer will be tested. So basically there are two stages. First, we will cover on training. Afterwards, we will cover on testing. Now, we're going to start with the MNIST of 0 to 9 folders. What we can do is so basically what data store does is that it doesn't really physically import in all the images because it will be too big. So it just access the file remotely. Now we go into creating the network. So this is the Deep Network Designer app. Okay, if you open it and let me just fast forward this one. So basically what you can do is that it will open up a window and you can select which kind of a base that you want to work with. So let's say if you already have something you worked with from the workspace, or there are also other pre-trained networks that you can use, AlexNet, GoogleNet, a lot more others. So this is basically the interface of it. What you can do here is and afterwards you can analyze, we have a digit 0, digit 1, digit 2, up until digit 9. After you have previewed it, then you can start with the training. So go to the training tab. First thing first, this training options window would pop up. And for this, if you already know what kind of a solver, settings like initial learning rate or maximum epochs to do, so you can insert them in. Okay, otherwise it will be like a trial and error, but that's okay. Now I'm just going to skip this one because it takes quite a while for to begin with the analysis and the training. Now, after you have a click on train, this is what it would look like. It would take around, for this demo, it would take around 1 minute plus. But sometimes depending on your training images, it would take up until like a few hours maybe. So if you see here, that all depends on the hardware resource here. So this one is done using GPU. If your computer doesn't have GPU, it depends on the CPU instead. So just going to skip, fast forward. So at the end of it, this is basically what it would look like. Let me just, okay. Now, if you have finished with the training, it will give out the results for the validation accuracy, which is around 93.9 for this demo, which is good enough. So after you have satisfied with it, you can just export it back into the workspace or generate code for your network. The next step is to test whether the network we trained is accurate, robust, or not against new data that the network hasn't seen yet. So we have a testing data folder to do so. Just like before, we have a training digits folder. Now we have a test folder. So for this one, we use the classify function to input in the network that we have trained, and as well as the testing folder using classify function. Then afterwards, the output will be of our predicted labels. Recall that I've mentioned about training data has subfolders labeled at 0 until 9. Now, that label for the training data, those are the true labels. Such the same thing can be said here for the testing folder. So basically from that folder, it's like folder 1, folder 2, folder 3. So those are the true labels. but the computer doesn't know it when it is being tested on. Now we want to see it side by side, how accurate the classification is. So as you can see, it runs repeatedly to see so that we can just test on the prediction that it has been through. Okay, we just want to see how accurate the network is. So roughly we can know that this one is acceptable. Now to recap, this is how you can use a deep network designer. The first step is, if you already have a model or operating network of your choice, load it up into the app and then drag and drop the layers on the canvas. So for example, this is just the basic of it, right? So you can also auto arrange if you want to make it neat, and also analyze, see that the layers connected are not complete, so it will give out error. Or you have already done so, then you can load it up in the workspace. So this is the one that is already made. Now, secondly, for the data preparation, we can go to the data tab, select the data that you want to import in. Now, deep learning, the data is typically large, so we use a data store. Okay, so then you can just split your training data to perform a validation. So again, this is to view the training data distribution, right? So I'm just going to skip this one. So after validation, if you feel like your model is not good enough, you can do hyperparameter tuning. So go to the training tab. Then there's a training options. Set your parameters. Then retrain the network to see the difference. Okay, so it's just a start of the training. So then you wait for the training progress to be done, and then after you're finally satisfied, you can either export the network to workspace, or in the future, if you feel that you need to train the data using this model again and the same processing steps, then click the generate code. Okay, so basically that's all for if you want to use a deep network designer to create your layers of a deep learning. So there's no need for a hand coding stuff and all. Okay. Now, next you can put your work to good use. That is to deploy it onto embedded devices, enterprise systems, cloud, or create standalone desktop apps. So two examples of deployment are shown here. Both are for optical defect detection of nuts. So on your left-hand side, here is to deploy onto a FPGA Xilinx board for prototyping. There are a few single line steps of code needed to compile, connect, and deploy to the board. So not to worry, the very minimal amount of coding needs to be done. Right, it's just a single line of a function. Then on the second, on your right hand side, what you can see is it also does the same thing, which is to detect the defect in a nut. So, but this time, this one is deployed on NVIDIA Jetson, which runs in a Linux platform. So yeah, this is basically an example of deep learning deployment. Now let's summarize the whole thing we have for today, followed by how you can learn more on MATLAB. So this is what Siti has shown. There are many reasons to start using MATLAB. First, it's relatively easy to use, and not to worry because there are many examples and complete documentation that you can follow. Second is because of the rapid prototyping and algorithm development. So you don't need to be a good programmer and manually code your work, as MATLAB apps are of high-level programming. And lastly, speaking of code, MATLAB does it automatically for use with just one click away to generate the function, the script, as well as to build application. Now, to learn more about MATLAB, you can head on to these links. not to worry, we'll be giving out you a copy of or the recording for this presentation afterwards. So we have come to the end. Please scan this QR code as a feedback for us to improve on our future webinar. So I'm just going to leave it for 10 seconds maybe, so you can scan them. All right, so I'll move on. So at Techsource, we also provide for the tutorials, workshop and trainings as requested by you. Then you can also Google for our online tutorial, which was made by MathWorks. This includes the fundamentals of MATLAB, which is called MATLAB on-ramp. Then there's a deep learning on-ramp, Simulink, Stateflow, and much more. So at the end of the day, after you have 100% complete the tutorial, you will receive a digital cert for each of the tutorial. So let's say for this seminar, I'm going to emphasize on a deep learning on-ramp. So what you've seen just now, you can experience it firsthand through the deep learning on-ramp tutorial. Okay. So other than that, we also provide webinars such as this or online workshop where we can assist you in getting familiar with MATLAB and Simulink for any specific topics of your choice, which is, for example, like today, as well as a training. Now, apart from that, we also provide a consulting service for users regarding how to implement MATLAB and Simulink to make your work easier, faster, and of improved quality. So the consulting service we offer includes how to effectively use MATLAB and Simulink in your work. Then the advisory service will be on industrial tasks such as enterprise integration, app development, and then cloud computing, so on and so forth. So we can also assist you in special projects, which is to extend and customize the tools that you use. Now, if there is anything that we can help you with, feel free to contact us via the respective emails shown. Now, I think we can open for a Q&A session.
Yeah, right now is the Q&A session. So you guys can you can either type out your questions. I think we have already had some questions on the chat. Otherwise, you can also unmute and just ask the questions. We'll be here for a while to entertain the questions.
Hello, Dr. Hanim.
Yeah.
I'm Sham.
Okay. Hi.
Saying I wrote a code using Fortran. Will it possible?
Sorry, what was it?
Saying I wrote a code using Fortran.
Mm-hmm.
Is there any interface so that I can use MATLAB?
Fortran. Let me see. Siti, do you know if Fortran can be incorporated with MATLAB?
Hi. Basically, you use Fortran for doing what? Can I know?
Yeah.
Yes.
I use Fortran to calculate the eigenvalue, eigenvectors.
Okay. So basically, for Fortran and MATLAB can interpret. You can import Fortran into the MATLAB and do the analysis basically.
I mean, is there an interface?
Interface?
Yeah, given by MATLAB. But sometimes the Fortran code is quite complicated, you know.
Yeah, that's when I need to check the GUI piece. But for now, I know it can collaborate with each other, but in the form of what we say automatically, we need to check it back, and I'll get back to you after I have the solution.
Okay, one more question regarding image processing. I would like to ask Dr. Hanim.
Yep.
Would it possible to identify the weight of mesh? Saying we use image processing on certain object. Would it possible to calculate or to identify the mass of the object or the stiffness of the object using image processing?
I think we can pass this to Siti because she's the expert in image processing.
Oh, okay, thank you very much.
So
all right.
basically, for the weight, There's a several way because we cannot see, we cannot evaluate the width inside the image, correct? So we can evaluate the depth inside the image. So basically, you need to calculate the depth of the image, and then you need to we inside the MATLAB we have stereo camera calibration and the depth estimation and so and the function. So the weight is more on the depth. And you know, you got what I mean?
Yeah.
Yeah, the depth, and then because I encountered like one case like they want to calculate the group of fish in the sea, but they doesn't know is similar of the weight, but we can propose is this is using the depth estimation, and you calculate the group, and you can have the size of the group, and then of course you need to have like the experiment on the relationship of that space or the depth to the weight.
Okay, saying we have a car, like a car body,
Yes.
and then we want to use image processing, and then from the image processing we can estimate the weight of the car so that we can also estimate the natural frequency of the car, something like that. Yeah, very possible.
That is something similar, like I say. You need to know the relationship between the depth, the image, and the network not created yet, but we can also convert it to C and C++ and to do the classification or disease classification by using the phone. Again, like I said, from the model that you train, and you can deploy to the you said Unity just now, right? But Unity is Android, am I right?
They want using C#. They want for game.
C#. Sorry. C#. But we do have Java converter. That is the closest thing we can do is Java or C++. And once you have the generated script from Java and C++ or C++, you can or even .NET, you can integrate to the third-party software.
Then after you train using deep learning,
yes,
everything, the data, training data for the circuit, everything, and as you want to test, is it 10% for that? You test it accurate or not? After that model,
yes,
sent to mobile. Is it?
Yeah, same. Because you just from the MATLAB perspective, you just convert the model. The model you already train and you already test and you already validate, and you already test it to your test data. That is your 10 or 20%. Once you already satisfy your accuracy, like 90% or 20% or whatever accuracy, yes, and then you take the model. Only the model is either ResNet model, LXNet, or exception nets, even. That's a net that we can convert to the C++ or Java, and that's the model only. Once you generate the models,
you put inside the phones, and they will do a real time. That means we snap a photo and we know this is the tree disease or not.
Yes, the model only. The model only.
Okay, is it faster?
I'm not recommended because MATLAB is really heavy computation site, because if you go run to the GPU, even I run it in the Jetson GPU, it's only take 70 frames per average, 70 plus. Yeah, if the Android phone, I'm not sure it will call, but it can be, because I tried in Raspberry Pi. It's lower end hardware, but the frame rate only like below than 30.
Is it depend of your train data or something? It's not effect.
No. The model only. The model is
the model come from
the train data and etc.
That means it's not good for real time, isn't it?
It's good for real time, but it's depend on your hardware.
Okay, thank you.
Okay. Any other question?
And Dr. Hanim, I think we have a very good audience today. We expected, as I discussed earlier with Mr. Andrew, we were discussing about 100 participants, but today, Alhamdulillah, we managed to get most of the time 250 participants, and I think all of us are very excited to use the software. I really hope everyone can fill up the attendance form and give a very positive comments, especially the section of using campus wide license. Yeah, hopefully we can extend the use MATLAB use in our PC. I have also downloaded MATLAB in my PC. I'm happily running it day in, day out, and I have a lot of cases to Mr. Andrew, and I hope everyone can also use the same, download the software, and if we can support our infrastructure request to show our interest in using MATLAB for ourselves and students, we can we can fill up the form and let the management know for us to use more of the software in PC. Yeah, and then I think the direction of university, direction UiTM sendiri, apabila kita memperkenalkan pelan strategik baru UiTM 2025, kita merancang kepada penggunaan software untuk menjana high impact research. So ini adalah salah satu agenda, bukan saja sesuatu fakulti, tapi juga adalah agenda utama UC Tajuk Mara sendiri. Alright, if there is any more questions, I'm sure Mr. Andrew, Dr. Siti and Dr. Hanim are willing to answer them. Ada lagi tak soalan?
Yeah, based on what Dr. Faisal, thank you, Dr. Faisal, for the MATLAB recommendation. So what's going to happen is I'm going to get the list of the participants right now from Dr. Faisal, and as he mentioned, I have given UiTM the free access to the campus-wide license for the time being. So what I'm going to do is I'm going to email you guys the link where you can download in case you missed it over the past few months, because what actually happened is I've given this campus-wide license to UiTM since April 9th, if I'm not mistaken. Yeah, so it's actually been over 2 months plus that you guys have access to it. In case you guys are not aware of it, I can send you guys the link again. There's still time, and also off the record here, I think there is a chance for me to even extend it further. There is a chance that I can extend this further in case there is interest. There's a lot of interest from the UiTM staff. There is a chance that I will increase this. I'll extend the duration of which you guys have the free campus-wide license. My aim for this is, as we go on during this time, I'm sure everybody will want to have access to some sort of computational software in order for you guys to do your research. I'm sure the government has already announced that they will be giving more research grants, this sort of thing. So I think MATLAB is really useful when it comes to doing your research, as well as for using it for teaching, having classes in which you can showcase the MATLAB functions to the students as well. So yeah, I'll get the list from Dr. Faisal, and then I will send you guys the campus-wide license list. Yeah.
Okay, do we have any more questions before we can wrap our session this morning, our wonderful session this morning?
Yeah. So if you guys have any questions, or maybe there's not enough time, I think we have already posted our emails on the slides, which I think Dr. Faisal, you'll pass a copy of the slides. We'll pass you a copy of the slides where you can pass it to the participants. Yeah, that we have our emails there, and I think we also have already posted the emails on the chat group. So if you guys have any questions, you can just forward the questions. I think just now itself I have 5 or 6 emails a day which I'm trying to answer now. So yeah, thank you so much for the support. Yeah, we have
to. I'm not sure whether we have answered this question. Muhammad Faizal Abdul Jabbar asked about color histogram to extract color feature, and then I think that I saw another one. Yeah, from Dr. No reason. No, from Muhammad Faizal. Method. Is there any method other than color histogram to extract the color feature where the color intensity is unknown? Not sure whether we have answered that one.
Siti, are you there?
Yeah. Basically, can I have his email so I can personally talk with him later on?
Yeah, okay. Muhammad
Yeah.
Faizal, can you uh,
Okay, thank you.
type
I
your
got it.
email?
Yeah. Okay.
Thank you.
All
All
right.
right. So if there is no more question, okay, I wish to end our session here, and I wish to say thank you to everyone for your time